Good day, students. Today we want to look at ionic substances. Okay, remember when you are going to form ionic substances, you need a metal and a non-metal. So, in the formation of all ionic substances, usually there's a metallic component and there's a non-metallic component. These ionic substances differ. There are some which are simple binary compounds, but some of these ionic compounds will be containing what we call polyatomic ions. So today I'm just going to demonstrate to you the easiest way for you to remember how to write the formulae of simple binary compounds which are ionic compounds. Okay, right. So I'm just going to look at two examples here and what we can do using the periodic table to write the formulae of ionic compounds. Okay, let us just start with a compound such as sodium. Okay, sodium oxide. All right, sodium oxide. This is an ionic substance because there is sodium part, which is the metal, and then there's the oxide part, which is a non-metal. Because it's an ionic compound, it means it has ions in it. Okay, so suppose I'm asked to write the formula of sodium oxide. What do? Okay, I go to my periodic table and I look for sodium. The formula of sodium is Na, okay? And oxide, obviously you're not going to find oxide on the periodic table. You're going to find oxygen, okay? That's step number one. Step number two, I need to establish the charges on these two species. Sodium is a metal, it's in group 1, okay? So for the metallic part of ionic substances, the rule is the charge on the metallic part is always equivalent to the group number, okay? Except for that group which is called the transition element. But for group 1, 2, and 3, I'm referring to those metals in the block, the S block of the periodic table. You're going to find out that it's actually going to be +1 because sodium is in group 1, okay? So the rule is the charge on the metal is equal to the group number. Sodium is in group 1, so it will have a charge of +1, okay? You have to remember that, okay? Let me just write that down, okay? Group number will be equivalent to the charge, okay, for metals. All right, so now I am dealing with the non-metallic part. The rule is the charge on the non-metallic part, we derive it by the following formula, okay? You will say group number minus 8 is equivalent to the charge for the non-metal. That's the rule, okay? Group number minus 8 is equal to the charge, or is equivalent to the charge. I look at oxygen. Oxygen is in group 6, okay? Then we simply say 6 minus 8, and then we get -2, okay? There is a reason why we're saying +1 and -2. That topic is also dealt when we are looking at the aim of all atoms to achieve noble gas configuration. But now, this is just a simple rule so that you can use it when you are dealing with some exam question. Now, I'll take this down, okay? I have written sodium, okay? My sodium is Na+1. My oxygen is -2, okay? So, what we do, okay? We swap the charges, all right? We swap the charges, the numbers at the top. We swap them, okay? Leave the sign, only take down the numbers. And you have the 2 comes to sodium, the 1 goes there, but we don't write the 1. So my formula for sodium oxide will be Na2O. Again, when you take down the numbers, leave the sign, only take down the number, but don't write 1. Leave 1, okay? And then, just to practice what we have learned today, I am asked to write down the formula for aluminium bromide. Aluminium bromide. What is the formula of aluminium bromide? I go to my periodic table, aluminium and bromine. I check the group number for aluminium, it's +3. Okay? Bromine is in group 7. So I would say 7 minus 8, and then I get -1. And what will be the next step? I swap. Okay? I swap. The numbers only, the sign remains upwards. And then my answer will be Al Br +3. That's how we write down the formulae of ionic substances. Okay, so students, that's what we're going to cover today. Please, if you like this video, remember to subscribe or even to share with some of your friends who will be studying chemistry, IGCSE, syllabus code 0620. Okay, I'll be covering formulae of ionic compounds, but those that contain polyatomic ions. Okay, it's bye-bye for now.